Morning, everybody. Second session of the first day. Welcome to Technical Metamorphosis, the 3 stages of DSAR automation. We have Alon, Levy, engineering manager with Uber, joining us today. So give him a warm welcome.
Thanks. Hello, everyone. My name is Alon Levy, and I'm an engineering manager on the technical privacy team at Uber. I lead the team that builds automation systems for exporting user data. At Uber, we've tried to take a proactive approach to privacy. So really, the main mission of my team is to optimize automation as much as possible, and then provide users with tooling around their data. I'd like to thank you for joining my presentation. The main focus is going to be data subject access request automation. So without further ado, let's get started. I'm going to be reviewing what exactly is a data subject access request, and then why are they important. And then for the benefit of other teams in earlier stages of their planning and development cycle, I'm going to walk you through the stages towards automation, and then share some of our experiences going through that process. So data subject access requests, what are they, and why should you care about them? A data subject access request, and from now on I'm going to refer to them by their common name, DSAR, is a legal right individuals have to access their personal data that's being processed by a business. So for example, a user can approach Uber and request their trip details or their order history or their profile information. They'll reach out to us, and then at the end of that process, they'll receive a compressed file with a copy of their data. These are rights of the individuals are spread across a disparate regulatory landscape, as you can see in this map. Each one of these laws basically has its own varying requirements, penalties, and stringent response times. Now, the main reason for showing you this map is not so much to educate you about these laws. Your legal departments can probably do a much better job than I can. I'm an engineer, not an attorney. But the bigger message here is that these laws are coming up all over the world, and you should view automation as a way of getting ahead of things and building both compliance and trust with your users preemptively. So what do things look like, kind of in the early stages of automation? Well, you're going to need to be able to define a clear and repeatable process, and then answer questions like, how do you ingest these requests? Who's going to undertake fulfillment? And then, what data do you actually need to provide? So here in this slide, you can see one possible such process. Users will be submitting DSARs to your business. Generally, those requests will be triaged, and afterwards, you can hand those off to support staff who can undertake manual fulfillment. What does manual fulfillment mean in this context? It could be running analytics queries on Presto, or running SQL queries against your databases, or making API calls. It really depends where your user data lives. So manual fulfillment tends to be both time-consuming and cost-prohibitive, so it's generally the most problematic step within this process. Another question you're going to need to answer is, what data do you actually need to provide? Or how do you keep track of data in a large organization? At Uber, we have a privacy review process that helps us both build and groom a data export backlog, and then make sure that it remains holistic. So whenever a new feature or product is introduced, a cross-functional team of privacy architects, engineers, data analysts, and legal review data processing activities, and then determine if they're in scope for export or not. So before we continue, one kind of brief but required detour. Whenever you're deliberating DSAR automation, the question of building versus buying is going to come up. There are many vendors with out-of-the-box solutions out there. Generally, as an engineer, my instincts are always to build in-house. I also have a terrific team, and then the support of our leaderships to build these types of tools internally. But I do realize that not everyone is going to have the same resources or engineering bandwidth, so I want to review slightly more generic criteria. The first one is the complexity of your system. If you take a look at the graph in this slide, that basically represents Uber's microservices architecture. Each one of these nodes represents a service. And honestly, I only really put it up here to basically demonstrate that systems can get pretty complex. Second is, are you dealing with a static use case, or are you continuously developing and evolving your system? It can sometimes be difficult to make sure a vendor solution can keep up with those changes. And then lastly, regardless of whichever solution you end up choosing, you're going to need to make sure that it integrates both with your infrastructure and with your tech stack. I'd like to share a recent case study that I read that was published by VentureBeat, where they described a hospitality company that was attempting to automate their DSAR response process. They engaged with a vendor and built a proof of concept. That proof of concept was incredibly promising, both in speed and efficiency, but then they didn't end up moving to production with it. And the main reason was because IT stepped in, stating that the long-term costs of maintaining that solution are going to outweigh the possible savings. And that's not really a singular example. That can tend to come up if you read more about it. So vendor solutions can be extremely effective, but you really need to make sure to carefully weigh the pros and cons within the context of your specific organization. And more generally, once your system goes beyond the monolithic, it can sometimes be tricky to make sure that those solutions work well for you. So now let's get back on track towards automation. Well, I defined the manual process just earlier, and the question comes up, what's wrong with it? Why can't you continue doing that indefinitely? And the answer is that things can change pretty rapidly, and that demand can escalate quickly. You can find yourself faced with thousands of requests on behalf of many users, all coming in at once. So the process by which an agent is compiling and running every single query for every user and request no longer scale. You can bring in your engineering and start working on partial or interim solutions. And you end up with a process that looks something like what I'm showing in this slide, where you have your fulfillment staff doing part of the fulfillment, then you have your engineers stepping in and doing the other part, and then they both converge together before transmitting the final output. So the next question is, what's wrong with that? Why can't you have your fulfillment staff doing the bulk of the operation, and then have engineering step in and provide partial solutions whenever required? And that generally can work, but the problem with it, it becomes pretty cumbersome. You now have to coordinate across multiple departments to fulfill DSARs: engineering, legal, and your support. And also, you now have engineers actively taking part in fulfillment. Engineers tend to be expensive, so it's not a great return on investment and not a great long-term solution. So the next question really is, could you avoid having to come up with these hybrid or partial solutions and try to target automation from the get-go? And the answer should generally be ideally yes. But in reality, it can be a bit difficult. Investments in initiatives like these can tend to lag. It's really difficult to continuously make the case before things start heating up in practice. So one thing you need to make sure is to properly quantify the true cost of manual fulfillment, and then communicate those risks effectively with the business. And generally, you need to make sure that your process can keep up with the demand. So now that we've kind of talked about the earlier stages, what does a fully automated solution actually look like in practice? I'm going to review our approach to automation, and we had 3 core requirements. The first one was adaptability. So business practices tend to change, and new features are released while old ones are discontinued. We needed to build a system that made it easy for us to onboard new data and then offboard data that's no longer required easily. Second was scale. So as I mentioned, demand tends to grow. We wanted to build a system that could naturally scale to accommodate that demand without having to revisit our architecture later on. And then lastly is cost. In addition to trying to minimize our operational and opportunity cost for our support and engineering, we also wanted to minimize our resource costs, which for us tends to basically mean compute. Now, I do realize that not every single construct is going to fit every unique use case perfectly. I still feel that reviewing our general considerations and approach can prove helpful for other teams going through these challenges. And I'm hoping they'll be able to adapt our approach to meet their needs. So this is what our automation tool looks like. I wanted to start by showing you exactly what we achieved through automation, so I can then kind of contrast that with what I was describing in stage 1, the manual process. This is an internal tool that allows our agents to submit DSAR requests. On the left, they can select the subject or subjects to include, and then on the right, they can select the required data. And then through these sequence of simple selections, they can submit a high volume of requests covering a wide array of data fairly easily. And you need to contrast that with what I was discussing earlier, where you'd have agents handcrafting queries, then running, compiling, formatting outputs for every single user and request. So this is a marked improvement on that. To power our system, we have 2 main components. The first one is our API layer, which essentially accepts requests from the UI you just saw, which consists of the user or users, and then the required data. And it stores it in our metadata storage for future processing. And the second component, which you can see on the bottom right, is our batch orchestrator, which basically kicks off processing on a fixed time-based recurrence. And it essentially reads all of our previously queued requests, batches them into composite export operations, and then kicks those off. And I'm going to talk about how you break down into export operations in just a bit. One thing that we found is that data requests tend to repeat. So it's very helpful if you can group all of the related data together. We called those groupings templates. And I'll give an example. In our case, we could have a writer template, which basically would include all the writer relevant information, like their trip history or their feedback from drivers. In the UI you saw earlier, I can select a single tick box, which would allow me to essentially pull all of that data in one go. Another thing that we wanted to achieve, like I mentioned, was to be able to onboard and offboard data very quickly. And the above data model kind of allows us to do just that. On the bottom, we have our data sources entity, which basically represents the underlying data and includes things like the column names or the table name. And on the top, we have our templates entity, which is essentially a container for data sources. So I mentioned our writer template just a minute ago. Imagine now you also have eaters requesting their data. You could go ahead and create an eaters category, then bring on the relevant data sources, like their historical order details or historical promotions, make the relevant connections, and then after several data quality and fidelity checks, you can onboard those to the tool, something that makes it a lot easier to be able to service those types of requests. And then more generally, it's easy for us to update our templates, our template memberships, our data sources, and our columns whenever required. So now that I've discussed how you capture requests and then how you define templates and data sources, what does processing actually look like on the back end? Well, imagine you have thousands of requests covering dozens of data sources all coming in at once. In order to be able to scale the system, you'll need to be able to break things down into manageable bytes. We've done that through introducing what we call the cuboid concept. It essentially represents the minimal unit of execution for us, and it's a grouping of users over a specific time range for a specific data source. You can think of a request being broken down into multiple cuboids, and then each one of those cuboids representing a subset of the overall data. This concept also allows us to scale our system, since it's entirely configurable on any one of these dimensions. You can either process more users at a time, a wider time range, or more data sources. And you can also easily control how many operations you're running in parallel. So all of those basically come together to allow us to scale our system with compute. And to illustrate that, what does breaking a request down into cuboids actually mean in practice? Imagine you had a request similar to the one that I'm showing in the slide. It covers users 1 through 300 for data source 1 through the years 2013 to 2017, and then data source 2 through the years 2015 to 2022. A possible breakdown into cuboids could be the one that I'm showing here, where cuboid 1 is exporting data for users 1 through 150, covering data source 1 through the years 2013 to 2015. Now, cuboid 2 is covering the same users and same data source, but a different time range. Each one of these operations will be executed independently, and then once they're all processed successfully, we can reconstruct the original request and then compose the final output. And this is another view kind of our cuboid in action. Imagine you had a request. It was broken down into multiple cuboids. But then, as you can see here indicated in red, cuboid 3 fails due to an infrastructure failure, for example. If you discarded the entire request, you'd be losing a lot of precious processing time. So we've basically built our system with checkpointing included. We can pick up our request from the latest point of failure and then make sure that we don't have to reprocess previously successful operations. The main idea behind it is to kind of salvage these green cuboids, which were successful, and then focus on retrying only the red ones which failed. This helps us also protect our system from overload and from cascading failures. So that was kind of an overview of our DSAR automation approach, but it plugs into a wider ecosystem of trying to provide richer insights through data export. Last year, we released our Privacy Center, which is available through Uber's suite of apps, and it includes features like Explore Your Data, which allows users to visualize and make sense of their data, and Download Your Data, which allows users to request a copy of some of their most pertinent data directly through the apps. The Privacy Center was very well received, but in all actuality, it's our investments in automation like the one I was describing today, which allows us to focus on features like the Privacy Center. It's our investments in automation that allows us to build not only for compliance, but also for user trust. So what am I hoping you take away from all of this today? I have a few final taglines. The first one is right process, right place, right time. You need to make sure that you fully understand your company's risk landscape and its data profile, and you can clearly assess if you need to build your own solution or if buying an existing solution is good enough. Second, you need to make the case for automation. You need to speak the language of the business, clearly quantify the true cost of manual fulfillment, and then the possible savings that can be gained through automation. And lastly, you need to build a robust system, which essentially means you need to make sure that your system can scale to growing demand, and then also that you can squeeze everything you can out of your resources. And I guess I have one final note, which is whether you're building for compliance or for trust, it's really an endless journey. And our DSAR automation is basically one milestone on that journey. But the road ahead is still very long. I still feel like we have a lot of things that we need to learn, improve, and do better. And we're going to strive to try and do exactly that. I'd like to thank you so much for your time and wish you a great rest of your conference. Sure, if there's any questions.
We do have mics here if you guys want to step up to the mics.
So my question is a very simple one. Do you use any of the popular market automated tools in your shop, or is everything just built in-house?
So mostly everything is built in-house. There's a few specific use cases where there are some vendor solutions.
Okay, right.
Thank you very much.
Sorry, thank you for that. I just wanted to ask a quick question, and I missed the first sort of 5 minutes, so you may have covered it just in case. But I see it as being something that assumes a very simple data subject request, because I'm just wondering, how do you accommodate the need to redact, for instance, in documentation that has other names in it or other personal data in it? And is that either kind of a phase 2 or something?
So I guess the things that I didn't really highlight in this presentation is it basically is part of a larger system. It also needs to be complemented by a categorization or classification or inventory system that would basically do, I think, what you're describing as far as redacting and associating the data with the correct user. Does that?
Yeah. So there's a missing piece, so to speak, thank you.
Yeah, you need to make sure that it's both accurate and complete, that you're not giving anything that you shouldn't be giving, and then you're giving everything you must, so yeah.
So I have a short question. So for DSR, right, you said first you need to know very detail of your systems, right? Does that mean, how to say, a vendor-provided solution will be quite tricky because they need to plug into multiple systems?
Yeah, it really depends, right? If you have an internal team building it, you can really customize the approach to your existing system. The second you're bringing in an outside provider, you need to make sure that it integrates with your identity system, with your data platform, if it has any AI or ML component, that it integrates with your compute correctly. That's where the trickiness comes in.
Okay. Another question is, when you collect all the information, could be potentially related to a name or whatever, a customer or employee, right? Will legal review and make a decision what are truly relevant from the legal standpoint, or?
Yeah, generally yes.
Okay, so your internal system has that some kind of approval or review process built in?
Yes, yeah, I mentioned that earlier in one of the earlier slides. We do have a privacy review process.
And I would say that, do you distinguish the DSR from your, for example, terminated employee versus customer, or you do the same workflow for everybody?
So essentially, kind of a tricky question. I think employee DSARs are becoming more and more prominent with recent legislation. And then, yeah, we basically include and modify our approach as appropriate, depending. Okay. It's a bit of a different story between the two, since they're stored in different systems and somewhat segregated, but the general approach will be similar.
Okay. And a last one. So when you initiate DSR search, right, will that process similar to your, how to say, e-discovery search, which was commonly used by the legal team, or it's a separate process?
Could you clarify the question?
Yeah, so before the concept of DSR, right, I think there was a popular practice by especially enterprise legal team and the technical team to do the e-discovery, right? Normally they would just do a keyword search for certain names or something, right? So do you think or in your practice, this process is carried over to handle DSR, or you have to build it separately?
Well, I'm not exactly sure if we had a specific discovery service like the one you're describing, so maybe built separately.
Okay. So how many years you have in building that in Uber?
So it's been several years now, I'd say.
Okay, thank you.
Okay, so I have one question. How do you prevent misuse of the system? So, for example, some support employee looking up where his girlfriend was driving.
So that's probably more comprehensive at Uber, and there is a pretty strong system for auditing and making sure of stuff like that. But as far as DSAR is concerned, basically our system has a lot of monitoring and telemetry and alerting. So we're able to detect which users requested what, when. We have an identity review process to make sure it's the correct person that's requesting it. And that's kind of how we safeguard against it. But yeah, it's probably a wider question.
Okay, thank you.
Sure. All right, unless there's anything else, I guess have a great extra 20 minutes or so. Thank you so much.